Hello, everyone, and welcome to Securing the Stack, our brand new ActiveState webinar series focused on everything container security. My name is Evan, and I'll be your moderator for today's session. And today we have a really awesome session lined up to talk about why containers aren't secure by default and really dive into some of the common misconceptions that are out there around container security. Just a bit of really quick housekeeping before we get started. Just so everyone knows, this session will be recorded and sent out following the call, so there's no need to worry if you miss anything or have to step away for a moment. And if you have any questions throughout today's session, please make use of the chat functionality to ask any questions. We're hoping to leave around 10 minutes or so at the end of today's session to go through those questions, and we'll answer them right at the end of this session. So without further ado, Mike and Leslie, would you like to introduce yourselves and tell us what you do at ActiveState?
Sure, yeah, I can start. My name is Mike. I am part of what we call the experiences team here. I'm a senior developer, and our team worked on a container pipeline that we use internally to deliver hardened containers.
Awesome.
And hi, everyone. I'm Leslie Pasquale, and I'm a senior solutions architect with our customer success team. And I help our customers secure their packages and containers.
Awesome. Great to have you both here. So, as mentioned, today we're really here to talk about container security and specifically some of the illusions and misconceptions teams may have when it comes to actually, safely building and deploying software using containers. I think at this point, it's fairly safe to say that many software teams are either already using containers or thinking about adopting them as some part of a, larger modernization effort within their business. And so, with that in mind, since you both have a technical background, I wanted to start and just ask you, what do you think the biggest misconceptions organizations still have around container security actually are? And I guess more importantly, why do you think these myths still persist in today's environment?
Yeah, so one that I see a lot is that containers are secure by default. And I think this comes from the isolation that containers provide. I mean, it's in the name in that they containerize the application and separate it a bit from the host operating system. But when you bring in a container, it will usually run on your own infrastructure or the wider internet. So there's network exposure. Even though these things are contained, they do still have a shared kernel with the host operating system. So there is a way to get out. And just like code that you bring in, there are supply chain risks with containers. So while it's true that they do provide a bit of isolation, there are a lot of ways to get out of a container and to potentially cause havoc.
Yeah, and I also, to add to that a bit, I also think that the misconception still exists because we think we're going to use the container, throw it up quickly, it does its job, and then it comes back down. So we maintain that fast-paced environment. But often, sometimes there's misconfigurations as well, like running a container with unnecessary elevated privileges, such as root privileges and stuff like that, which is common and actually often dangerous as well.
Right. Those both make a lot of sense. And I think too, there's sort of also some stuff that I'm thinking about around just sort of the status quo of, where container development often starts from. I think, many teams go to places like Docker Hub or other public repositories to kind of begin their container journey. Can you tell me a little bit about like why that might present some problems and why people going there and seeing things like official images and images from open source providers might present some trouble?
Yeah, going to Docker Hub, sometimes developers may think that it's a trusted source, and but sometimes they're bringing these containers down without thoroughly being vetted, and thinking that they might be production ready. But often, these images, even the official ones, contain hundreds of CVEs in their base layers, the operating system packages. These vulnerabilities are product of out-of-date components that haven't been patched. They're also not maintained as frequently, for example, as some of what we do here at ActiveState.
Yeah, and if you do want to see this for yourself, there are a bunch of tools out there called SCA tools that will scan Docker images for you. And you can pick a pretty popular community image and run an SCA tool against it, and you will see generally quite a few vulnerabilities in a lot of them.
Yeah, absolutely. And with these public images, you actually end up inheriting the entire security debt that you just downloaded.
Yep.
So with that in mind, like I guess like, for me, a question that comes up is like if I pull or a team pulls a container image from a place like Docker Hub or really any public registry, what are some of those actual risks that my team might inherit without really like realizing that we've done so?
So, yeah, I think you need to treat images from Docker Hub like you would code from the internet. So when you pull an image from a Docker registry, you're sort of inheriting everything that's baked into that image. So we already touched on
Mhm.
the vulnerabilities, which is one. A lot of them will have excess dependencies that you might not explicitly need for running your application. Inside of those containers, there can be things like scripts. It could be making network calls, so a lot of unintended behavior. Some can even be malicious, and there's a bunch of other things. Some images will have embedded secrets, and transitive supply chain risks. There's a ton of stuff that you're taking on when you're pulling in an image from Docker Hub.
Yeah, and these community images, they're built by anyone. So there is a lack of provenance and trust there as well. So unless you have a rigorous process in place for scanning, for remediating, those are all things that you're inheriting without even knowing.
Right. So let's say, I go to Docker Hub and I pull, let's say, the Python community image. And Mike, you mentioned before these SCA tools, I have those integrated into my tooling, my pipeline, and, we pull that image and immediately it flags a bunch of CVE show up. We got to go deal with this. What does that actually mean? I guess not only for the security side of things, but for my development team, for the engineers in my organization. Like, can we just fix these CVEs once and we're good to go? What does the sort of process of dealing with these CVEs actually look like from the engineer perspective?
Yeah, so I will call out a bit like just fix.
Yeah.
It's so sometimes fixing a vulnerability is simple as bumping a patch version on a vulnerability, and that's fine, or on a library, sorry, and that's fine because it's super simple and it just will work generally. Sometimes, in order to remediate a vulnerability, you'll have to bump a major version or something else, or maybe use a different library entirely. That's going to require you to use different source code or change your source code to work with the new library, which is can be a lot of engineering time to get that up and running. So no, you can't just. Well, okay, sorry, step back. You can just fix it, but new vulnerabilities pop up all the time. So we've spent all of this time to potentially change our source code to work with a new version of a library, and we patched it. And if we are regularly running SCA tools, we will see maybe in a week, in a month, in a year, new vulnerabilities are going to pop up. So unfortunately, it's not a one-time fix. This is a kind of quickly moving space, and there's always new stuff to be patched.
Yeah, absolutely, Mike. And I'm just thinking, open source moves so quickly, it's so
Yep.
broadly used that CVEs are discovered every single day, things are being flagged, and the level of severity is also comes into play here and what that vulnerability exposes, right? So now you're having your developers spending extra effort on patches and updates and making sure that the base layer components that they're trying to use and build software with is CVE free, so vulnerability free. And that takes a lot of time. It takes a lot of effort. It's a lot of heavy lifting for teams. The other thing is that we do see some false positives. We don't know, or even a false negative. Those are things to consider as well.
Yep, for sure.
Right. And I imagine based on that, teams are probably having to do some amount of this triaging work too to determine like, hey, do these things even matter for us? Do we have to actually go and spend this effort? And I'm sure that's a whole other can of worms that developers probably don't really want to get their hands into.
Yeah, absolutely. And I've seen it where teams are managing multiple containers, so the remediation process can 16x or 10x, or I've actually seen those numbers where modifying a base layer has turned into then having to maintain and an exponentially level number of containers to get that image remediated across the board.
Right. So, I mean, this sort of gets me thinking about another component of both, I guess, software development generally, but also container images, which is dealing with your application dependencies and sort of the larger software supply chain that's involved in development. We talked about, going to Docker Hub and pulling these images, typically base images that you're going to build on top of, just kind of start yourself down the container development cycle. But how are teams incorporating things like language libraries into their containers today? I assume, to run and deploy your application, you're often going to need to get things from, where you typically might have got them before on the internet. And I would assume this process for containers isn't too far off from just how you would typically use like a standard package manager today. Is that true?
Yeah, that's exactly it. So most of the times when you're building a container nowadays, you will pick a base image and then use whatever language or operating system tooling to get things on there, like apt-get or pip for Python, npm, that kind of stuff. Some development teams will also choose to pick a base image for the language itself. So you can pick a Python 3.12 base image. And with the language images, those bring in a lot of unnecessary tooling a lot of the times, like compilers, debuggers, extra packages that you might not necessarily need, and also some dependency bloat that you might not need just to run your application. So all of this extra stuff that both the package managers and the language specific images bring in just sort of expand the attack surface of an image and just increase your vulnerability risk.
Yeah, absolutely. And I've seen it too, again, with that fast-paced environment of coding. Um, we often do these things, and I speak as a developer as well, an engineer as well. We make these decisions last minute, right? Like we're trying to get something
Yep.
in, we're trying to get it to work. So we
Yep.
rely on the package manager as the implicit source of truth. We think it's safe, so they're popular, they're available to the public, so it must be safe. And it creates, as you mentioned, Mike, a massive attack surface, and then on top of that, it's unmanaged as well.
That's really interesting. So, I guess, like, for an example, if I go and just, blindly grab packages from places like NPM or PyPy, or I guess even like Maven, like, what are some of the risks I might be exposing my container to? I assume, we've seen a lot of challenges around supply chain security as of late. I assume those exact same risks can get pulled right into my container.
Yeah,
Yes,
definitely. Oh, sorry. Go
yeah,
ahead. Go ahead, Leslie.
no, I was just going to say that there's a lot of opportunity for code injection and backdoor attack as well. But one of the ones that I think is the trickiest is typo squatting. So where they'll change like one letter of the package that you're trying to download and it becomes popular, and all of a sudden that one small typo knowingly pulls down malware for you. Um, so that's a funky one that I've seen out there that folks like to that happens.
Yeah, for sure. And a lot of the stuff out there, like a lot of the open source stuff is, maintained by volunteers. It's not patched regularly. So things like version drift can happen. And yeah, you're just exposing yourself to a lot of risk for sure.
Mhm.
Right. Yeah. I think it's, I mean, I'm not the expert, but I saw, some of the recent NPM attacks, and it's kind of wild to think that some of them just sort of originated with a phishing attack on a maintainer of one of those repositories. And, once some code gets inside there, people just sort of trust that, yeah, it's in X, Y, and Z repository. It's safe to use. I can pull it into my container, no problem. So, um, I guess sort of
Yep.
just the long tail of supply chain security impacting containers is something that again, really needs to be thought about when you're building and running these things.
Yeah, for sure. Like, again, a lot of people I do think that things being open source is also inherently secure. But it's humans reviewing this code. So someone will put a patch in, someone from out on the internet will patch an open source library, and people will be taking a look at it. And sometimes we miss things.
Right. And so I guess, you know, as someone who sort of exists outside of the software development space like myself, and really sort of just like a total layman, like I hear you both talk about the risks in places like Docker Hub and in these package management solutions. And what knowledge I do have in this space sort of tells me like these are the tools that people use to do this work. Like these are the places you go for containers, these are the tools you go for your language libraries. And so if I'm not using those, like what are my options to get around this?
Yeah, so I think tackling this problem yourself is definitely one option. So, learning about image hardening and what that takes. So, securing a base image and all of the requirements that are there, and then making sure that the dependencies you pull in are as minimal as possible. So, like we said at the start of this webinar, I was part of the team that wrote our pipeline that creates secure images. And I can tell you from experience that it's no small undertaking. It took us a lot of time and effort to not only configure like the base operating system in a way that was secure, but also make sure that the dependencies that come in are secure. And like at Active State, we leaned on our platform. Which builds all of these dependencies from source. So that's another step that you would have to take if you were trying to build these yourself, was rather than pulling these packages in from the internet, either build them yourself or get them from a trusted source. So yeah, there's a lot of steps to produce a secure images, but there is tooling out there that you can run against your images, which will give you a score as to like how hardened your image is. But yeah, no small undertaking for sure.
Yeah, and I've seen it with our customers actually. I actually really think that Active State's platform is very neat for creating these containers. I was able to actually run this comparison recently with a customer who was using a public AWS container, and it had a lot of CVEs, it had a lot of packages. I think it was like 500 plus packages. We were able to recreate the container in Active State platform, and we were able to significantly reduce the number of packages that were brought in, reducing that attack surface and eliminate all of the CVEs. Also upgrade packages that the client really needed to be upgraded in order to remove those CVEs and be able to do that quickly. Our platform is great for doing that. And it was really nice to be able to show that comparison from a community container to a container created by Active State for that customer.
That's awesome. So, like we said at the top of this session, this one very much an intro to sort of container security, and we wanted to make sure we also left a lot of time to tackle any questions in the chat as we are sort of just diving right into this topic. So, with that in mind, I'm going to get some questions going for you both, if that makes sense for you.
Sure, yeah.
Yeah.
Awesome. So we've got a couple of questions from the chat in the Q&A panel here. I will read them out to you, and you guys can tackle them how you best see fit. So the first one comes in here from David, and it says, aside from vulnerabilities in the image, is it possible to get into a container ecosystem because of lack of security and permissions in the internal container network?
That is a good question. So I think it depends a lot on the capabilities of your tools and infrastructure team and how they secure your internal network. But yeah, every network has ways to get in. I think what we focus on in this panel is ways to get into the network from a container, but from outside, definitely you can get attacks into the internal network, and I think that has happened at Active State a few times. Um, and from the internal network, then depending on the configuration of the container, then maybe they could get into the containers themselves, like get into potentially a database container and do some damage there. There are It depends on the image configuration and on the hardened images. Again, this is drastically reduced, but yeah, in a lot of images, I think there might be a way in.
Awesome. Sort of like a related question. There's one here that says, what security checklist can we apply to a container ecosystem aside from just dealing with the vulnerabilities in the images? And I think, um, Mike, I know you did a lot of work on our own sort of set
Yeah.
of container images, and I think some of the work we did around like the minimization and like you just described, the hardening, I think applies to this, but I'll let you speak to this one too.
No, yeah, that's exactly it. So there are tools out there that can scan images and give you a hardening score. But in terms of like actual things that you can do, one of them is having a read-only file system on the image itself, not running as root, reducing all of the transitive dependencies that you're pulling in, making sure that if you're running the container and you do need to modify things that you're volume mounting, like there's a lot of technical detail that we can get into. I would say look into tooling and run those against your containers because they give you a really, really good output and insight into what further steps you can make to harden them.
Awesome. And I will do a quick shameless plug. I believe we do have a container security checklist asset floating around there. So maybe we
Ah,
can
yeah.
include that with the recording of this webinar. I will talk to the organizers and we can see what we can do. But yeah, I think, Mike, what you said is great. And I think, too, it's almost worth noting, like going back to the base image discussion, like how just using one of these bloated container images from a public repository kind of puts you on the wrong foot right from the get-go. Like, here's a bunch of unnecessary software you have to deal with. Like, it's just, I know the question sort of asked, like, aside from dealing with the vulnerabilities, but I think having
Mhm.
these massive images kind of just sets you down the path to um, go and have to deal with that later, regardless of what you do up front.
Yeah, just kind of building on what you're saying. A lot of the community images don't come with the operating system configured in a way that would be accepted as a hardened image. So, they will run as root. They do have a read-write file system, and a bunch of other things are included that aren't necessary to run an application. But they do this because so they can be general purpose and run a bunch of different applications. So it's really good for like prototyping and testing. But when it comes time to deploying something to production, that's when you really want to have that extra layer of security.
Awesome. So maybe Leslie, I'll send a question your way, and here's one from the panel I'm looking at, and it says, if a team wants to reduce their risk without maybe completely overhauling their process today, like what's a practical step they can do to sort of better vet their container security or their dependencies?
So actually, I'm going to do a shameless plug here and say go with Active State. It's actually one of the reasons I joined Active State. I know firsthand what it's like to govern these containers, to do CVE governance as well in an engineering team. That's where my background is from. And Active State does that for you. So shameless plug, we have a lot of components and dependencies that we build from source, and we go through that process of providing that minimalist hardened container, of managing CVEs consistently, of raising those alerts for CVEs as well. So really great solution, and like I said, that's one of actually the reasons I joined. It's great, and yeah.
Awesome. So another question came in, and I think this is sort of related to what we were talking about in regards to the base image. And it says, doesn't using Alpine or Debian-based container images help reduce the vulnerability problem you described? Um,
Um, Maybe. So
Yeah.
every
Yeah.
operating every operating system is going to come with a different set of vulnerabilities, most likely. There might be some that, are will have fewer. Um, but yeah, everyone is going to come with risks. So yeah, the not really. It would be my answer to that question, I guess.
cool. And then maybe I'll just ask a follow-up that for my own knowledge too. And
Sure.
it's if that's the case, like when we talk about vulnerabilities in container images, where are they usually mostly coming from? Is it from those OS level components? Is that sort of the majority of where the vulnerabilities are going to live?
Yeah, so we see them come from both, honestly. I don't know where most of them come from. I think it depends on like the size of the application that you're layering on top of the image. Like if you have a huge application that's running on top of a pretty minimal operating system, then the bulk of your vulnerabilities are probably going to be in that application layer. Um, so yeah, they come from both operating system and application level vulnerabilities.
Right. Okay, I'm going to take a quick look here and see if there's any more questions.
Sure.
I think we sort of touched on this one, but I'll ask it again. We've got the time. It says, "Is
Yeah.
there a good way to deal with transitive dependencies? How can I secure my supply chain if my requirements have requirements?"
So I'll start with that one, and then Mike, you can add on to that a little
Sure.
bit. But continuous monitoring, we've covered some of that with using an SDA tool, and then you have to prioritize remediation, right? Um, and and that tool doesn't map to a direct dependency. How do you manage that as well? And then also you're going to have a vetting policy also for these dependencies. Um, so before adding a new dependency, how are you vetting it? How are you doing what's its age, the maintenance frequency, the size? Those are things that you can use or start to ask yourself before even putting it into your application.
Yeah, definitely. Those are really good steps to take. Transitive dependencies are a tough one. There are some language ecosystems that will, allow you to modify the transitive dependencies, but a lot of the time that's just sort of up to the language ecosystem itself to determine what transitive dependencies it needs to build something. A good start is probably using the latest version of a library. And again, another plug for active state, we build everything from source here. So we build not only the application or the dependency that you need, but we build all of its transitive dependencies as well. So when you use a package from us, you know that everything that you're getting has been built from source and vetted and secure. And one other thing, just to plug for open source, if you do find a vulnerability in a transitive dependency, you could always make an open source contribution yourself to fix it, or reach out to the maintainer and maybe they could do a patch as well.
Awesome. Thank you. So it looks like that is it for questions, which is perfect timing because we are running up on time here. So just before we go, I want to say, as mentioned, we will send out the recording of today's session. We'll also send out a link to register for the next episode in this webinar series. And I think this next webinar is going to do a great job of sort of going one layer deeper and sort of diving into some of the solutions we sort of hinted upon in this session on things like image hardening, minimization. And so that session's titled Securing the Pipeline, Turning Vulnerable Containers into Trusted Assets. And the date is there at the bottom as well. So with that, yeah, thank you very much, everyone, for joining. Thank you, Mike. Thank you, Leslie. This was a great conversation. And I am looking forward to seeing everyone in the next session.
Awesome. Thanks for having us.
All right, thank you.
Thank you.
Thanks.